Okay, hello everyone. Good morning. Um, Let me just link you quickly. It should be on the website up now, but we are going to be starting on our new Year 10 topic today on motion. Now, if you've been following my conservation and dissipation of energy streams for Year 9 content, but doing a little bit of revision as it's paper 1, then you probably would be able to breeze past today's lesson quite a bit because it's mainly surrounding calculations, but it also goes into a bit of detail into scalars and vectors. Remember in a previous topic we talked about what a scalar quantity is and what a vector quantity is? Well, we're going to be revisiting that today in this lesson on speed versus velocity. Now, in the link that I just gave, it's on the website under GCSE Physics Paper 2. But in the link that I gave, once again, I have notes booklets for you to use, both in PDF and Word document files. There's FT for foundation tier, HT for higher tier. I'm going to be teaching higher tier content, but I will say this is higher tier. So this applies to foundation as well. So if you're taking foundation, don't just switch it off, but I will explicitly say when something is higher tier. Today's lesson is going to be foundation tier included. So everything today will be both foundation and higher. Right. I'll give people just some time to download and open up the notes now. I'll give about 1 minute for you guys to do that. Let me just link it again for anyone who's missed it, because then that way you can type things out. Okay, right, let's get started then. So, just as a quick recap, remember that there's something called a scalar quantity and something called a vector quantity to start off with. Now have a think to see if you can remember the difference between the two. Remember what a scalar quantity is basically a quantity or a measurement that only has something called magnitude, so how much there is. That's it. But with a vector quantity, it has magnitude, so how much, but also it needs to be specified in a particular direction. So in a scalar quantity, direction doesn't matter. So if you're changing direction or anything like that, that doesn't matter. But with a vector quantity, any change in direction does matter. It makes a huge difference in what the final measurement is going to be. So let's relate this to speed and velocity then. Speed is a scalar quantity. So it's basically just a measure of how fast you're going. You can also word it as how much distance slash, I'm going to put steps covered over a period of time. What I mean by that is, let's say that you were running around in circles. You were just going around in circles. Basically, your speed is like how much actual distance, steps that you covered in that short amount of time. So you can go faster or slower depending on how many steps you're taking in 5 seconds or 10 seconds or anything like that. So speed is just how fast are you. That's it. Direction does not matter. With a vector quantity though, it is speed, it's the same as speed, but direction matters. How fast you're going in a particular direction. Now, what that means is that we have a difference in how we calculate for these two. So speed, the equation that we would have learned in maths before as well, is speed equals distance over time. That's an equation you do have to memorize. So speed is typically measured in meters per second, so meters covered per second. Distance is measured in meters. Time is measured in seconds. Velocity is the same thing. It's also measured in meters per second. But then we have something known as displacement, which is measured in meters, and time, which is measured in seconds. Now, we've talked about this word displacement before in our last topic, in our forces topic, when we first introduced scalars and vectors. Displacement, remember, is because we care about the direction, it's how far you are from your start point. So if I just scroll down here, to give you guys a visual example, so distance is like the amount of steps. Amount of steps / ground covered. But displacement is distance from starting point. The reason why is because we only care about the overall direction it's gone, because the overall direction matters. Whereas if you look at this example here with this little bee flying about, it's changing direction all the time. But we're only caring about the distance, so we don't really care about the change in direction. But displacement is a distance, but because we also care about the direction, we then have to take into consideration the overall direction it's going, which is just a straight shot from point A to point B. And we're not really concerned about all of these changes in direction overall because we care about the overall direction it has gone. So displacement is a measure of distance from its starting position. So if you notice, our velocity equation is displacement over time. So what happens then if you run in a circle? Say you're on a track. You start by here, there's the starting point, and then you're running in a circle around the track. And let's say that you've, say this is a 400-meter track, circular track, and you did this in, we'll say 40 seconds. So it took you 40 seconds to run. Well, when you calculate for speed, in this example, you just go speed equals distance over time. So speed equals 400 divided by 40, which makes 10. But your velocity, have a think about what your velocity is going to be. Because you return to your starting point, your displacement is 0. Because you have traveled 0 distance from your starting point. So you have 0 displacement. So when it comes to velocity equals displacement over time, the value that I would put for displacement is not 400, which is the distance of the circular track. The value I would put in is 0. Let me get, where's my pen? So it'll be 0 over 40, which is just 0 meters per second. So even though you're moving very, very quickly, you're moving at 10 meters per second, your speed is 10 meters per second, but your velocity is 0. Now, if you remember, in a previous stream when we did the forces topic and we talked about distance versus displacement, I had given a point, I mentioned something where let's say that you died in the same hospital you were born at. And I mentioned that your overall displacement then would be 0 because you had not moved from your starting point in the overall total sum of your life. In that same vein, your average velocity then throughout the entirety of your life would have been 0 velocity because your displacement was 0. So even though speed and velocity are pretty much almost used interchangeably, like people use them to mean the same thing, there is that small difference. Because velocity is to do with it, because velocity is a vector quantity, we care about the direction, so we measure the overall direction that it's traveled as well. Well, if you haven't moved from your starting point, you haven't overall traveled from any particular direction. So that way your displacement 0 and your velocity is also 0. Now, oof, I made my person go pretty fast then. Right. Um anyway, I hate to be the bearer of bad news, year 10 or year 9 in the future, but you're going to have to memorize these typical speeds. I also recommend that with a car, memorize an easy number. So pick a number that's easy. Let's say we're going. I would go like with 15 or 20 or something like that. You don't need to memorize 13 over 30. I'll tell you how they usually ask this question. They usually wouldn't just say state the typical walking speed. They would ask you to calculate something and say, how does this compare to the typical walking speed? But they wouldn't tell you the typical walking speed. So like they would say, oh, this truck is traveling at 40 meters per second. How does this compare to the typical speed of a car? And then you would say, oh, it goes faster than the typical speed of a car, not by much, by about 10 meters per second. That would be what you say, something like that. But you see, the trick is here, if they ask you that, if they ask you typical speed for a truck is 40 meters per second, how does that compare to a car? And you didn't remember the typical speed of a car, then you wouldn't be able to answer the question. So they wouldn't just explicitly state, tell me the running speed, tell me the cycling speed. Have an idea of the typical speeds, so that way you can use them as a point of comparison to something else. This is one of those things where the more you have a look at these typical speeds, and we're going to be using them quite a bit because these are, general things that are in day-to-day life, walking, running, cycling, car, train, airplane, because they're typical means of travel. In this motion topic, we're going to be working with them a lot, so I'm hoping that over that time, you guys will get used to them more and more. But it is worth putting them on flashcards just as a bit of memorization of these typical speeds. But yes, I'm sorry to be the bearer of bad news for that one. Okay, now for a bit of practice. Here's an example. I'll go with, let me just write out this example question. Make that font bigger. There we go. A car is traveling at a speed of 30 meters per second. If it remains at the speed for 50 meters, how long does that journey take? So always remember, let me change to a different font so it has a greater contrast. Always remember the FIFA method. Make a list of your values to make things easy for you later. Then write formula, insert values, fine-tune, answer. So if you've been with me for previous streams, then you'll know this method off by heart already, and you'll be sick to death of it, but it gets you full marks every time, which is why I say it again and again, to hopefully that it becomes a habit where you can do it in your sleep then. But let me go through it again. A car is traveling at a speed of 30 meters per second. Anytime there's information, I recommend giving it a quick underline and then writing it down. So speed of 30 meters per second. I'll make my list here. Speed equals 30 meters per second. If it remains at the speed for 50 meters, 50 meters is a distance because it's measured in meters. This is where knowing units comes in. Distance equals 50 meters. How long does this journey take? Well, that is asking me for a time. How long does it take? That's a time. Time is a question mark. Now, first stage of FIFA is writing out the formula. And remember, the reason why we do this is because it'll then make things easier for us when we substitute things in later, so we don't have to substitute in our heads and leave room for a silly mistake that you guys can easily avoid. Formula is speed equals distance over time. Now, next step, insert values. So substitute things in. Use what you've made in your list. This is why you have the list. The reason why I ask you to make the list is for two reasons. First is because they might not tell you what formula that they want you to use. Making a list with all of the values that you have on the left side would make it easier for you to spot then what formula you have to use. Like for example, I see speed, distance, time. Oh, I need the speed, distance, time equation. Things like that. Another benefit of making the list is because then you don't, every time you substitute things in, you don't have to go back to this wordy question to find the value. You already have a list of values. So after you make the list, don't even bother reading out the question anymore. You don't need to read it because you already made a list of all the information that you have. So another room for error is needing to go back and read this block of text over and over again. So speed equals distance over time. Let's substitute something in for speed first. I look at my list. Do I have something? Yes, I do. I have 30 is equal to distance. Do I have something for distance? Yes, I do. That's 50. Time. Do I have something for time? No, I don't. So I'm going to leave that as t. I'll write t instead of time. So I've already gotten the mark now for substituting things in. Now I'm going to fine tune. So basically, how you say in maths is solving for the variable, solving for the unknown variable. Let me write this out again. So 30 equals 50 over t. Remember, the t right now is a denominator, as it is. It's at the bottom of a fraction. When we want to solve for t, we want to bring it to the top. Now remember, if you've been following my conservation and dissipation of energy streams, you'll know that the quick an easy way to rearrange this is to just swap these two numbers around, these two values around. So you're with t equals 50 over 30. Let me just re-explain why that works the long way. So 30 equals 50 over t. I want to bring t to the top. The way I do that is by timesing both sides by t. So now it's at the top here. It's no longer denominator. This t and that t cancel each other out. So you're left with t times 30 times t equals 50. Then I divide both sides by 30. So the 30s cancel out by here, and you're left with t equals 50 over 30. Notice that is the exact same as that. Basically, this little swapping method is just saving you the time to do all of these steps, because this is just that with more steps. But it's up to you what you're more comfortable with. If you want to do it long ways, do it long ways. That's fine. But the key thing is, remember, when you rearrange, when you start off rearranging for an unknown that is in a denominator, you have to bring it to the top first. That's a key thing to remember, regardless of what method you use. Then I just stick in my calculator 50 over 30 to find a value for t. 50 divided by 30 is 1.6 recurring, but I'll round it to one decimal place, 1.7. And time is measured in seconds. So that is my final answer. And that's the last part of FIFA. Stating the answer with units. Okay. Now let's do an example for you guys to have a go at. So I'll put the example up and then wait, let's say 5 minutes for you guys to do, and then give you the answer to see how we've done. So here is my example. A car is traveling at 20 meters per second. How far will the car travel in 120 seconds? Remember, the fine-tune part might not be exactly the same as what we have up here. You might have to rearrange it differently, but the key idea is just like you do in maths, you just rearrange for the missing variable. You just solve for it. So formula, insert, make a list, formula, insert values, fine-tune, answer. So give 5 minutes for you guys to have a go at that, then I'll go over the answer. Okay, ideally that should have been enough time for us to get that done. Right, let's go over the answer then. So a car is traveling at 20 meters per second. That is a speed or a velocity. So speed equals 20 meters per second. How far will the car travel? How far? That's asking me for distance equals question mark. Will the car travel in 120 seconds? So time equals 120 seconds. Write out my formula. Speed equals distance over time. Substitute things in. Speed, I have 20. Distance, I don't have anything. I'm going to leave it as D. Over time as 120. Now, our variable's already at the top, so I don't need to move it or anything like that. I can get rid of the 120 by timesing both sides by 120. Those cancel out, and then you're left with distance is 120 times by 20, which is 2400 meters. So 2,400 meters should have been your final answer. Hopefully we all got that. Okay, so now for a bit of practice then. I'm going to link the Google, it's on the website, but I'm going to link directly to the Google Drive as well. So on the left side, you'll see a worksheet. Once again, let me just remind you, this is optional, so you don't need to do any of the questions. You don't need to submit it to me or anything. But I do recommend you having a go at a few of them just to make it so that you feel confident in what you're doing. On the right-hand side is a PowerPoint. And at the very last page of that PowerPoint are the answers to that worksheet. So all 16 questions, the answers should be on there for you to check your answers. Obviously, don't go jumping straight into the answers at the very start. That defeats the point. This is just for you to do a few problems, look at the answers and think, oh yeah, I've done great. I'm fine with calculating for speed and velocity, not a problem, and then moving on. So that's just for you to develop your confidence there. So I'll leave you to it then. If there's a particular answer on my answer sheet that you're not sure how I got and you'd like to Sorry, my mic keeps turning off. If there's a particular answer, you're not sure how I got that answer, and you'd like to see the workings, feel free to send me an email, leave a comment on the video, or leave a comment on Show My Homework, and I'd be very, very happy to show the workings to you, so then you'd be able to know how I got a particular answer if you got stuck somewhere. Okay? Right, guys, have a good rest of the day. I am going to just let you know what we have planned in the future though. We're going to be next lesson we're going to be moving on to distance time graphs and then calculating for acceleration and some velocity time graphs. So this is quite a maths heavy topic full of calculations and graphs, which is exciting to me. Some of you might like it, some of you may not, but the whole point is for us to all be confident on it because with a lot of this, it's easy, simple, straightforward marks if we wrap our heads around it. Okay? So know what a scalar vector is. Know that speed is a scalar, velocity is a vector. Know that distance is a scalar, displacement is a vector, and then use that information with the equation speed equals distance over time, velocity equals displacement over time to be able to use the FIFA method and calculate for using those equations. All right? Have a good rest of the day. I hope you all take care. Bye.